Welcome to the Bug Bash podcast, where we talk about all things software correctness and reliability. I'm your host, David Wynn. Is it a fact of life that software is just broken? Our industry often operates as if the answer is yes. We write tests, we fix bugs, but we seem to accept that a certain level of failure is just the cost of the way we do business. Isaac Van Doren is tired of it. In today's episode, I sit down with Isaac, a software engineer at Paytient, who makes the case for a shift in how we approach software reliability. He thinks reliability shouldn't simply be about testing. Instead, we should adopt practices that force us to be explicit about the rules of our system and all the downstream implications that come from that. Using assertions liberally as a tool for building a theory of the system, those unmissable signals then fail loudly and proudly whenever reality decides to take a different turn from our theory. If that sounds interesting to you, stick around. Today, we have on the show Isaac Van Doren. So in podcast tradition, Isaac, could you please tell us a little bit about yourself?
Yeah, I'm Isaac Van Doren. I'm a software engineer. I work here at a company called Paytient, where we're trying to make it easier for people to access and afford healthcare. I'm also a big fan of software reliability. So going to Bug Bash 2025, I felt like I had arrived, like it was my people, from across industries. Finally, it's a group of developers who are all excited about making software that actually works and works consistently. And when we're talking about software reliability, that's a big reason why I'm really excited about functional programming, for one, the Rock programming language, which is very exciting. You should look into. Also, running assertions in production, another excellent tool for reliability, and that's what we're here to talk about today.
Okay, that makes sense. So as we think about, you're known as a bit of, let's just say, being on Team Pro assertions. Let's put it that way. And not just in test suites, but in code itself. So it's all code, I suppose, but in prod, so to speak. So how does that play out with the systems that you work on at Paytient?
Well, we just started writing assertions in our production code 6 months or so ago. And so this is the new development here, and we're working on rolling it out. It's in building the muscle of learning to build software in this way and get used to thinking about using using assertions in the code you write. But the standard paradigm is that, or the way we do it here at least, is that all assertions are run in all environments all the time, exactly the same. There's no configuration there, so you never have to think that your behavior might be different between different environments. If an assertion fails, it fails loudly. It blows up. It does not log something quietly and then keep going. It'll explode right there in a controlled way so that you know this thing failed, this went wrong. And the golden rule when it comes to writing assertions here is that every time an assertion fails, that must mean that there was a bug. So there can be no other explanation. It must be that there was a bug. And that's one of the big appeals of writing assertions, is that unlike other sorts of errors that may be expected, if an assertion fails, there is a bug that I wrote in my system that I need to go fix right now. And so it cuts through all of the noise, gives you this piece of clarity saying, there's a bug, and here's a good hint about what went wrong.
So clarify that for me, because how do you bake that into an assert statement that this is a bug? I can make a lot of statements about things that I've written that I don't know if I could confidently say were bugs so much as just I'm not very good at translating my intention. So how do you do that?
Well, and that's a great question. And I think one thing that sort of comes up for me when you say that is when you're writing code, you might make a statement about it and sort of not really be sure. What is this right? Is this not? And one of the core things about having assertions that fail loudly, that run all the time, is it produces this really virtuous feedback loop. So if I'm going to put a little bomb in my code that might blow up, it's a really good incentive for me to figure out if I actually believe that this statement should be true or not. So that's a key reason there, because I want to be very confident that I understand how my system's working. And oftentimes I think we just don't because it's so complicated. It takes so much time trying to figure it out. So we cut corners and stop thinking about how it really works. If you write an assertion, you're committing. You're raising your hand in the middle of class when professor asks if the answer is yes or no. You are fully committing, and that sort of brings you into the code base and engages you in a way that you might not be engaged otherwise because you're making that sort of commitment. So I think there was another question there that I have not answered, but that I just want to say that first.
That's fair. You could go on, or I do have another question on what you were talking about just there.
Yeah, go for it.
So what does one of these assertions look like exactly? Is it as simple as like this should never be null, and so we're sort of asserting away null inside of our data model, or is it something more complicated on the logic side? Do you guys have guidelines around, I could imagine that you would want to occasionally assert some things about the greater state of the data that exists maybe over in this database. And it's like, all right, well, everything has to be local, or we can't make any network round trips, or we can't call anything in, you can call anything in the cluster, but not anything in S3. Or do you have any guidelines for what those look like?
Yeah, that's an excellent question. So uh, from the nuts and bolts level, we just have a little library that has one method. The class is called invariant. The method is true. You say invariant is true, pass in a Boolean expression, can be any Boolean expression, and then a string explaining what invariant it is that you are asserting there. And I want to take a moment to talk about the fact that I'm not calling this assertion, I'm calling this invariant. And I think that's a key thing here, is that I don't really care about the fact that I'm writing an assertion. I'm not like assertions, whatever, that's just a detail. The thing that matters is invariant or property or rule. I'm thinking about some higher level rule that must apply to my system at all times. And this assertion is a way that I can state this rule is in fact going to apply right here, and I'm committing to that. So then as far as, what sort of things can you assert, what can you put in there? Well, it's anything, because you can put any Boolean expression, and it's the responsibility of the developer to make sure that you don't do something dumb. Because yeah, I don't want to have my production code taking all this time doing multiple round trips to S3, loading a bunch of data just so I can check some assertion right there in line. So you need to be responsible about that. And that's another reason that I like having it then run in every environment consistently, because then you never have any sort of inconsistent performance between staging or production, or you never have some assertions that could run in production, but some that can't because these ones you wrote in staging hit S3 and that's too expensive to use in production. And then you mentioned, oh, you might want to assert something about a data model or something in this database. And we didn't even talk about this, but you're teeing me up perfectly here. So I appreciate that. And that is another thing that we just introduced 2 weeks ago. Along the same vein of enforcing these invariants is these sort of asynchronous enforcement of larger scale invariants in the database. So what I mean specifically is that we have a folder in the root of the first project we're implementing this in, where we have broken up by team. We have a bunch of SQL files, and each of those SQL files returns a count, only a number of rows. And each one of those represents an invariant that must always be true of our data. And then every day we run those against a read replica. And if one of those queries returns any rows or a non-zero count, then we'll send a message out in Slack and say, hey, this invariant was broken. We expect this to be true over this whole database, and then it wasn't in this one way. And that I'm very excited about that. We've already caught a bunch of issues using that. And the key thing about that is that allows us to enforce larger scale invariants that would perhaps be too expensive to compute with just an inline runtime assertion, because we're running those less frequently.
Mm-hmm. Boy, the more you describe it, it starts to sound a lot like unit testing that grows into end-to-end testing, right? Like it's got some interesting parallels in terms of where we're trying to keep things tight, local, fast feedback, or in this case, fail fast, bomb fast, as it were. And then, we got some heavier duty lifts that really depend on different aspects of the system. We got to broaden this out in a sense and put this over here. How do you guys integrate this into your testing practice? Like, do you guys think of it as testing? Is it a different modality of thinking? How does it come together in sort of the mental model of how you guys construct the system?
Yeah, I don't think of it as testing myself, but I do think of it as a practice we use to ensure the correctness and reliability of our systems. And I
Hmm.
think I like having I mean, it doesn't really matter what the distinction is, but I think oftentimes when people think of what it is to improve the reliability of a system, the only thing you ever think of is testing. So it's
Hmm.
just testing. We
And a
just need to do better
particular,
testing, more testing.
yeah, and a particular definition of testing.
Yeah, yeah, and I think that's prohibitively narrow often, where testing is an excellent tool. You absolutely need to be doing testing, but that's one of the many tools that are at our disposal to improve the reliability of our system. So I think of this as a different tool that is complementary with testing that you should also be doing in addition to the other sorts of testing that you're used to. And it feeds in nicely with conventional unit testing or other sorts of really any sort of unit end-to-end integration, any of those sorts of testing, or perhaps any kind of testing, which is once you put assertions in your production code, it means that when you're writing a test in the development process, you're more likely to find bugs because those assertions in your code might fail when you're running your unit tests. And this can also help make sure that you're actually writing unit tests that make sense, or any sort of test that makes sense, because you have this extra validation baked into your code. So there have been multiple times now where I've introduce some assertions in the code expressing some property I expect, and then find out, oh, this test has bad data that doesn't even make sense because I'm writing this test, that data is not flowing through all of the normal validation, or maybe there's missing validation. It's not obvious how to construct valid data there. And now that I added this assertion in my code is giving me better feedback and telling me, hey, look, you did something wrong. And so now I can write better unit tests because of that. So it's sort of a rising tide lifts all boats sort of situation.
Hmm. And surely there is some of the, if resilience is really a question about confidence, not only in terms of what we're doing, but also what we think the system itself can do, you're essentially spreading the work out with different approaches to the problem in different sections of practice, right? Because there is a place for traditional testing as people know it. There is a place for understanding invariants under all conditions, right? Because effectively, correct me if I'm wrong, but what I'm hearing you describe is if we always check for invariants, because those things should never change, that should be true at any point, at any place, anywhere inside of the code base, at any time. So we run it all the time, everywhere, doing all the things. If there are specific examples that help serve as light posts to get to working, right, to get to where we want the code to go, that can be a great place for some more traditional based testing, or regressions can be a great place for, like, this thing really slipped us up a little bit. Make sure that that comes back to bite us. But picking an example out of the ether one at a time and writing them down is not a great way to describe invariance, right? It's a way to write down
Absolutely.
5 math problems that get at what addition is, not what actually describes what addition is.
Absolutely. And when you write a unit test, now you have a nice concrete example of something that you expect to work in the system. And you can look at that and sort of digest it and see, this is how things work. These are the inputs and outputs. But that's just an example. If you're trying to prove a theorem, you can't just do a bunch of examples. You have to have some higher level sort of argument. But if you don't have the examples, you can't get any sort of intuition about how that theorem actually works. So I think it's really nice to have both of them. And
Yeah.
and a thing I'd like to point out also about assertions is a huge pitfall with most kinds of testing is that you're just testing the things that you think of. You're writing down these examples. And even if you go property-based testing, which is amazing, you're still only testing all the things that the computer thinks to generate. There could be there are usually an infinite number of inputs. Your property based testing tool is going to try to generate as many interesting inputs as it can, but it's ultimately picking a finite set of inputs. With assertions, you don't get any of that nice example stuff that's useful, but you do get the property that this will be checked in every single circumstance, even ones that you don't think of, even ones that your property-based testing tool doesn't come up with. It will always be checked. It will in every single circumstance. And I think that's really magical and shows a way that it sort of complements traditional testing, where it fills that blind spot that even if you don't exercise that case, you still have an assertion that is going to make sure that that invariant holds.
Are you guys at Patient doing some sort of generative testing in this way? Are you guys doing property-based testing? Are you generating and fuzzing a bunch of data and throwing it at it, or is that's on the roadmap and looks like it's 3/4
That's
away?
that's on the roadmap. No, we are not
Mhm.
doing that right now. But after going to Bug Bash, I wrote that down on my list of things to do, explore property-based testing in the product because I got all excited about it, and so it's a long list of things of improvements to make, things to do. So we'll see when I get to it, but I would definitely like to look into it, and I'm sure that there are places that we could apply it fruitfully here.
You bring up I think you bring up a really great framing around thinking defensively with whatever you want to use, because if you're in rock you have different commands, and if you're in C you have different commands, right? Like
Hmm.
whatever we're calling this, I'm going to use assert as a general term here. So now well, it's usually lowercase, but you get the idea. We're generalizing the term assert here to mean whatever. Because you're taking this more defensive approach, this invariant approach, whereas we stand firm that this is what it is, all other things are invalid, becomes simply a matter of can we generate them enough. And I liked your point around with property-based testing, it will generate what you expect it to generate. And we actually work with customers a bunch who are generating lots of different types of data. And we're like, well, have you thought about badly generating that data a little bit? We call
Yeah,
it
totally.
bugification. Yeah. I remember when I was doing some ETL work a long time ago, I was supposed to get an XML document back for a person, and it clearly cut off somewhere not at the end of the file, so it wasn't a valid XML fragment. And when I submitted to get it fixed and the API finally turned around, I checked it again, and it was still submitting that bad fragment back, but now it was an escaped string inside of a valid XML doc. And I was like, thanks guys. That didn't really help me, but technically we
Yeah,
fixed the glitch.
right.
But in any case, like if you take the defensive stance, you've got all these possibilities that are now open to you. And it's simply a matter of how do we get in just enough of that to make sure that the system is resilient to it, whether it's premature in the file, whether it's network stuff like reordering packets or any other kind of thing like that is all open.
Right.
All right, there's a couple
And
of
and
curiosity questions. No, I'll let you go ahead. Go ahead.
it's like property-based testing, except you don't have to do any of the hard parts of property-based testing because your users will generate data for you.
Mm-hmm.
And rightfully you should be thinking, well, I don't want these to expect that these things are going to fail, but it's absolutely you should do other sorts of testing. But it's nice because you have these amazing data generators, which are your users, which will put the most realistic data possible into your system because it is the real data your system is using.
Yeah. Don't forget their cats who are sitting on their keyboards as we speak.
Exactly.
Mm-hmm. Now, so this isn't popular. I don't know if you knew that, Isaac, but this is
Yeah.
not
Yeah.
exactly a popular position to hold. Why do you think that is?
Well, part of it is because of the mindset that reliability equals testing.
Mm.
So I don't think people look outside of the box. They don't think what other approaches could we use? So another example in the statically typed functional programming world, something we love is the idea of making illegal states unrepresentable, which is another thing you can use to get correctness, where you say, I'm going to encode these rules in the type system. Say, for example, that this field must be present, or I have some enum and each enum value has different data associated with it. So you're clearly describing the states that are allowed. So that's an example where now I can just rule out all of these sorts of issues at runtime, but that has nothing to do with testing. So we need to break the mindset that testing is the only thing that's important to do for correctness. That's just one thing, and there are many other tools to use. Then the other part is that uh, understandably, people are scared about the idea of putting little bombs in their code because you don't want your code to crash. And if you don't put those, if you don't make them crash in production, then you're losing a huge amount of the value, and then it doesn't make as much sense to do. And uh, and on top of that, it's just not popular. I think it absolutely could be popular, but maybe just not enough work has been done to popularize it, or the accidents of history haven't lined up to make it a common practice. But I certainly think we could change that because once you get used to it and you start using it, it it feels very it feels like you're learning some vocabulary that you didn't have before. And now you can express these ideas that are so valuable and helpful that used to be inexpressible in the words you were talking with in the past.
Mm-hmm. Well, I'll turn that around on you because you mentioned that Paytient was only doing this as of 6 months ago or so, as of recording right now. There were years before that they weren't. Why not?
I guess because nobody had the idea to do it. I mean,
Mm.
I don't know exactly where I got the idea from. I perhaps some of it was inspired by hearing about Tiger Beetle. You know,
Mhm.
they run a lot of assertions in production. There's some people have done this for some time, so hearing about it more, thinking about it more. But I guess the story of where well, I'll share the story, the sort of experiences that I encountered that made me really want to have something like this here, and that is. We've been around for several years. We have a very feature-rich product, and because of that, the code does a lot of stuff. And so I've been many times, I've been in a situation where I've needed to go change some core assumptions of how the system works that have been in place for 5 years, maybe. So I go look at this piece of code. It's being depended on by several different parts of our product. And I need to change some of those core ways that this thing works. And that's really hard. I think that's one of the hardest things that we do as software engineers, figuring out how to change those sort of things without breaking them. So and spend so much time focusing, trying to understand how this thing works. And then I finally have this aha moment and realize, look, this whole code path doesn't even make sense. It should never happen because this is impossible. But it's not communicated in the code. And so then the author thought that they needed to handle that. That made me think I would so like to be able to write down, hey, this thing should never happen. If it happens, it means it's a bug and you need to fix it right now. And then I can get rid of that whole other code path and simplify this really hard problem that I'm working on. That was really the motivation for it. And I think other people had sort of felt that pain once I talked about it more. And so I made a proposal to adopt them and here we are. But also um it's valuable, but it's hard. You know, it's a practice you have to learn. It's not the sort of thing that you just start doing and say, "Oh, this is immediately obvious and amazing and wonderful." It's something I've been practicing. Is thinking this way. Oh, yeah, I should put an assertion there, even though maybe I wouldn't have done that in the past. So it's sort of thing you have to work at, like any skill.
Well, how'd you convince the team that it was a good idea to deploy at a wider scale? Because I know I have an intuition as to what it would be like if I went to my boss and said, I think we should just absolutely bail at several different points if it doesn't go exactly how we expected. And it's not the
Yeah, totally.
easiest story to tell. So how did you go about doing it?
Absolutely. And I think that a first thing to clarify before we get there is that, I've talked about how you're putting little bombs in your code base. And
Yeah.
I like saying that because you're putting little bombs that will explode. But the key thing is that they're little. And so a better analogy is perhaps a fuse. And I have to give TW credit for this because he's the one who came up with it. And it's a wonderful analogy, which is if you have a fuse in an electrical circuit, if I don't know, the current is too high or something, I don't know the details of how it works, then that fuse will break. It'll prevent other components from being damaged. Now, it broke. Your lights are not turning back on until you replace that fuse, but that failure is now much more localized and much easier to deal with. So that's the idea with this, is that I don't want to make our system more brittle. I don't want to introduce more places where things can fail significantly if a condition is not met. But I really don't want something very bad to happen in our database. So say we're dealing with money here. I would much, much rather have an assertion fail and say, hey, there's a bug, I can't continue, than have some addition go wrong or some calculation that results in me billing a member twice as much as I really should be. That's terrible. That's really bad. That's bad for the member, bad for the company, probably illegal in some way. So the idea is let's fail when we know something has gone wrong, instead of venturing into no man's land and hoping that our code happens to do something good and not something really bad. So when you motivate it like that, it becomes an easier sell because I'm saying we're going to start catching these issues right when they happen instead of letting something really bad happen that we might not even know about. Because there are lots of times where in many systems, where something goes wrong, you have some really significant bug, and you don't even know about it because nothing crashes. Maybe the numbers are just wrong, and no one has a way of determining that they're wrong, or no one does the work to look and figure out that they're wrong. So it is, let's surface that, pull that forward earlier.
Mm-hmm.
So
Totally.
okay, so that's sort of the motivation of why we should be doing this, and it makes it feel more reasonable because we're trying to prevent these really bad things from happening by a slightly bad thing from happening instead. The other thing is that you need to implement assertions in a way that makes sense for your domain. So in our case, we're writing web servers, and I don't if an assertion fails in one isolated corner of my server, I don't want that to result in all of production going down. That would be horrible. I would not sleep. That would be terrible. So the idea, how we have it implemented for our use case instead, is that when an assertion fails, that request completely fails, returns a 500, unrecoverable, but everything else in the server keeps operating as expected. Because just because there's something that went wrong in the code for handling one request doesn't mean that I need to shut down everything else. So that also really limits the blast radius, where yes, you're getting this feedback, you're going to know immediately when something goes wrong, but it's just isolated to the code that has the issue in it. So okay,
Gotcha.
that's more of the why this might be reasonable to do. But
A
then the
more
question is, how
palatable
do you
version, I
actually?
might say. Yeah.
Yeah, absolutely. Then the question is, how do you actually convince people to do this? And well, that's something ongoing. I mean, I think of our teams, I think someone on every team have used at least one assertion, which is quite exciting. You know that we've got a lot. They're spreading, but they're still not fully adopted, I would say. So that's ongoing. But I think one thing is you need to remind people frequently because people forget. You can't just say something once and expect that people are going to change their behavior. So reminding people, pointing out opportunities when this tool could be useful. Say if something went wrong and it was a big pain, saying there's a bigger invariant here. If we had enforced that, maybe we would have caught this earlier. And then showing proof of when it does actually solve problems. So I got sort of lucky in that fairly soon after introducing this, it caught a bug I caught a bug that had existed for 3 or 4 years in the system that was not identifiable because it just had to do with some numbers being wrong, and it affected a small number of users. So we were unlikely to have that notified to us. And fortunately, it didn't manifest in a really bad way, but it was very clear to see how it could have been much worse. So that was good social proof. Like, look, we did this practice and now we actually got a clear benefit from it. So I think you just have to sort of keep doing that over and over again uh, until it becomes a norm.
Yeah. We've found at Antithesis as one of the things that we do is we have a very assertion forward strategy as well. And there is reminder and there is also habit, because I think when one of the teams was reading back some of the things they'd written for one of the new features, they said they had an assert every 10 lines or so in what they were writing. And they said, except for the tricky parts. The tricky parts, we had one every 3. And it's just like, it becomes a great guardrail that if you leave it going, does give you a wider and wider, or I think of it sometimes like a net, right? Like a net with only a handful of strands in it doesn't catch very much because a bunch just goes straight through the middle. But the more and more lines you have on top of it, the tighter and tighter your net gets. And so you can be more and more confident in the correctness of the behavior. So there's all different ways to handle that. Oh man, there's so many different directions that I wrote down that were so good we could go. Well, so Isaac, I understand that you're not exactly what most people would consider the tech hub of America. Is that a fair thing to say?
That's a fair thing to say. Yep.
Okay, which for those listening is?
Columbia, Missouri. Yep. So
Mm-hmm.
I'm glad you mentioned it because you might be saying, "What are you doing building something highly technical in flyover country?" You know, and this is good because this gives me an opportunity to brag about Columbia, my hometown, and I guess Missouri, my state in general. Um, which, well, one, it's just a wonderful place to live. I mean, we have an excellent food scene, excellent music scene, world-class trail and park network. You should come visit and go to the True False Film Festival every March, which is we have people come in from all over the world for this film festival.
No. I got to
Uh,
pause you there. What is a true false film festival?
Oh, that's just the name. It's sort of
Well,
I
I
think
got
the idea
that.
is that it's very thought-provoking perhaps, and sort of makes you think a lot. So I saw a movie, Predators, at the film at the festival in March, and that was one of the most powerful movies I've ever seen. And it just sort of breaks your brain because you're now dealing with, like, it thrashes you back and forth morally, and it's so challenging trying to realize what you believe and confront your own emotions as you watch this movie. So I think that's maybe a good picture of what the festival's about, is sort of making you uncomfortable almost, or pushing you into your own emotions through film.
Okay.
But
So
it's
so
wonderful.
I'll
Not everything is that heavy. So
yeah. I'll so there's lots of great things going on here in
yeah.
Columbia, Missouri. And but we're getting that was all the extra stuff. Like we're getting to the
Yes.
tech part next, right?
Yes. Tech part next. So Patient was founded here. Well, first, Columbia is where the University of Missouri is. And so
Mm.
there's a lot of good because of that. But Patient was founded several years ago here in Columbia. We have about 60 or so employees in Colombia, and another 100 or so that are remote. So that's something, the population here is like 130,000. So your talent pool is more limited, and that the ability of remote work is great because that opens up the possibility that you can hire from broader markets. But there are a lot of great software engineers and great people in general in this area. And there's a long line of very successful companies that have been founded here in Colombia specifically. So, like Veterans United Home Loans, the number one VA lender in the nation, Equipment Share, they're a multi-billion-dollar company founded in 2015 or something, backed by Y Combinator. I think they might be IPOing soon. Zapier, founded here. I just heard they were like at the front of OpenAI's latest release or something. Carfax, founded here in Colombia, still operates here. So there's a lot of good stuff going on in Colombia. But if you're asking, why am I here? Well, this is where my family's from. This is where my wife's family's from. It's a wonderful place to live. So it's really really a great gig.
Hmm. Okay, I think that's a reasonable pitch for Columbia. And
Yeah.
if you need to buy a house, should people call you, Isaac?
Yes, definitely. Yeah, you'll look at wherever you're living, and then look at the house prices here, and yeah, and you'll understand.
Yeah, I live in Atlanta, and people have a similar reaction when I talk to them. Some of my friends from back in the Bay.
Yeah.
Awesome. Gosh, well, let's open up the floor a little bit. Isaac, what should I have asked you that I haven't asked you yet?
Mm. That's Well, this isn't perhaps a question. That's something that I'd just like to say a little bit more, which
No,
is,
that's
you
fair.
alluded to this a little bit, that uh, there are some parallels here between, say, the different sorts of testing, unit testing, end-to-end testing, and that's absolutely true. So I like to think of there being sort of a pyramid when it comes to different sorts of tools we use to enforce invariance. At the top is making illegal states unrepresentable. The idea is preventing these things from happening at compile time. This is the best, absolutely the best, because it means your programming language is enforcing for you that this will never happen. And so a lot of pure functional programmers, they might hear me talking about running assertions, and they might think, but that's so much worse because this thing could actually fail at runtime. Why don't we just rule it out? And it's absolutely true. If you can rule it out, you should. It's the best because it's the most reliable. It's also gives you the fastest feedback because you get feedback immediately there in your editor, a red squiggly line or a type error, whatever it is. You get that fastest feedback. It's the most safe, but it's also the most limited. There's this. It's much larger than you think, but there's the smallest number of things that you can enforce with the type system or something like that. So then you move down to the next layer of the pyramid, and you have runtime assertions. And there, you still get relatively fast feedback, and that as you write tests, you see these assertions failing, and you get more power because now you can check any Boolean expression that you can compute with that assertion. So it's not limited by what you can enforce with your type system. But you notice now it's a little bit less safe because you said this might fail in production, and you get a little bit slower feedback because now you actually have to run your code to make sure that those assertions evaluate those assertions. And then we go to the bottom of the pyramid, and that's where we have this asynchronous data validation or enforcing data invariance, perhaps, where now you have the most power. you're not limited to whatever data you have in scope. You can touch your whole database, and you can do things that are much more expensive to compute because you're not running this in your production code. And you can more easily bake in exclusions, if there's some known bad data that you want to rule out, or if you have some sort of condition that requires a time window. Like something that came up at work was we have this process that runs asynchronously, and so there's some invariant that must be true on the long arc, but it's not going to be true for like an hour after this action is taken. We expect that. Well, now I can really easily encode that in a SQL query and say after the hour range has passed, I expect this invariant to always be true. So now you have the most power, but it's the slowest feedback because it's only running nightly or hourly or something like that. And it's the least safe because you're still allowing everything to happen. You're just trying to learn about it the next day instead of 2 months down the line. I think bringing this whole pyramid together, you have three different tools that allow you to explicitly say what these invariants are and then enforce them at different times. And I really want to get into a world where we use all of those more. And I think it's just a wonderful collection of tools that you can use to make sure that those invariants all hold.
For sure. What sort of, all right, so you mentioned you were thinking about dabbling in property-based testing. I'll put you on the spot here just a touch. So invariants are obviously one flavor of property, which are a great one, but sometimes can be a little bit tricky to discover, even in the systems that we're writing, right? Like they're sometimes easy to see in the small and harder to see in the big, right? Eventually consistent is almost an easy one if you are willing to put some level of bounds on it. So you can say the system should eventually be consistent within 12 hours, period, for whatever the rolling window is that we decide we want to be consistent for to give it enough time to catch up. But there are plenty of others that you could use. Have you been tinkering around with any of those in your head and might be incorporated into this style of architecting?
Yeah, well, I'm glad that you asked that because I think it's a good clarification to make is that, perhaps invariant is not the best choice of word, perhaps property is better. But I think when people hear invariant, they may, especially if you have a distributed systems background, you might think distributed systems stuff like consistency, for example, or you think Jepson, you think something about like how my transactions are interacting, all that. And those are absolutely invariants, but they can be much more specific to your domain and much less grand, I suppose. So one example is, it's an invariant that you should never have a payment in your system that doesn't have a payment method associated with it. And I think that feels like a very different in character to like my system obeys strong consistency or something like that. Um, and so it's really just
you're almost talking about business logic there.
Absolutely. That is the primary thing I'm talking about is business logic. That's the only thing I'm talking about, really. I mean, I think I don't think it needs to be distinguished between business and other sorts of logic. It's like the only reason we're writing logic is for the business, So that most definitely. And another example, say we have an employer benefit. If that employer, if they roll off the benefit, then none of the people that they were paying for should have access anymore. That just makes sense. And that's an invariant you can enforce. Or you can say, there are different kinds of repayment that make sense in different circumstances. So enforce that everyone is in the right sort of repayment process given the circumstance they're in. Or yeah. So really any sort of that's what I'm thinking about mainly is in business logic. And so maybe I just need to rebrand and pick a better term that people get the idea more. But what matters is that it's a rule that's you always expect to hold true in your system, and then you're encoding that.
Yeah, well, we can rebrand the term however we like. I find in most of my conversations, I tend to use the phrase checks or rules just because I find properties is already an overloaded term, and I'm trying to figure out which objects I'm attaching it to and so on and so forth. It's like, but as you drift into that domain, Isaac, so what do you, now I'm curious how you guys interact with different teams that might be responsible for some of the logic there at sort of higher and higher levels, right? Like it's not going to be entirely the software engineering team that's coming up with all of those different invariants, are there?
Yeah, I think it absolutely should be. I think it absolutely should be the software engineering team, and I think
Yeah.
this is not industry standard belief, but it's certainly mine, which is that you should most definitely operate the software that you build and be fully responsible for it. I think
Hmm.
this again, it's a much better feedback loop if that's the case. Because if I view myself as a device that takes money and produces code, that's one thing. And so maybe I take my money and I produce my code, and then someone else deals with it. Product support team, whatever. They look at all the bad data, they get it sorted out. But that's a really bad model, and unfortunately, it's quite common. Where instead, I'm fully responsible for this product. I'm working with the rest of the business to understand what problem it is we're solving, what the problem really is, what our solution really is. How do we know that our solution is working properly? And so I think it absolutely should be the responsibility of the software engineers, even if it perhaps is not in some circumstances. And another thing to associate with that is like, if you're writing code, how are you supposed to know if your code works if you don't know what right means? So this is really just part of, we're just defining what correct means with
Hmm.
these rules. And there's no way I can produce code correctly if I don't know what correct means.
Hmm. Do you guys have a method with what you have implemented or in the middle of implementing that recombines all of the distributed invariants you have encoded inside the system and pulls them all back together? Because the one thing that strikes me about the approach is that there is almost certainly someone or a set of someone's who are going to want to see everything that we guarantee in one place and understand if that is the approach that we want to take, or if the nature of the model sort of means that it's a diffuse thing and it has its own nerves and each of its different nodes and services, and you have to trust in its nature in that way. Is there a way to combine them all back together?
Well, I mean, you could do a text search and look at all the usages, for example. And so that you
Rep is
could
always there for you
absolutely
till
do that.
ripgrap comes along. Yeah.
Yep. Yep. But I don't know that that would be valuable in all cases. Um, and part of this is because sometimes we're asserting two different things, where it might be that there's a property that would be interesting to look at when you're thinking about your whole system, but that might not always be the case, because it might be sometimes I'm just asserting I have this API here, that application there, this other service. They're all feeding into this service I'm writing. And I have validation at each of those boundaries, perhaps. But now I'm writing some code and I write an assertion, okay, this data is always invalid. Should never be allowed. And I'm sort of maybe duplicating some validation logic there further down in the system, saying I expect that this is always going to be true right here. And that's a very useful thing to do. But that may not be a relevant property that makes sense to look at on a large scale, because it might be very specific to that particular piece of code you're writing right there. So for a lot of these inline assertions, they don't always make sense to pull out. Some of them certainly do. But I think what would make more sense to look at from a global perspective is the invariants that you're enforcing over your database with those SQL files, because those are not bound into a specific context. They don't care about the specific piece of code you're running them within. Those are statements about your data, which is, in my view, really the heart of your application. Um, so and those already are naturally centralized all in one folder. There's not, a pretty UI around them, but we could certainly build something like that to uh, highlight those higher level rules about how the system works.
Mm, gotcha. So here's a question for you, Isaac. Do you think that the nature of the business that Patience is in, or the experience that you've had that's been embedded in that industry, colors your expectations and your approach here in terms of how you go about implementing these types of invariances, or the word just sprung to mind, assurances, however you want to phrase it?
It certainly does. It certainly does. Because every day I'm confronted with the fact that if the software I write works incorrectly, it will be very bad. So it's a constant reminder. And
That's
but
very
I
different
don't
from my
think
life. My life, if I write bad software, it's no problem, but that's a different story.
Yeah. There's plenty of software I write that doesn't. It's fine if it breaks because maybe it's just some internal thing. Few people are using it. I can fix it quickly, whatever. But I'm often writing software that is definitely not fine if it breaks, and I think that's true. Usually, is that some of what you're writing is really critical and some isn't. Um, so that definitely reinforces my feeling of the importance of reliability and correctness. But I don't think it's just from that. And someone asked me on a podcast I just recorded last week where this sort of passion or jadedness I have about software being broken came from. And I don't really have that great of an answer, honestly. Like I guess it's just from seeing the software in the we use in the world and kind of being fed up with it being broken all the time. So like just earlier today, for example, the booking software we use, they shipped a bug recently where now when you try to book a room like the one I'm in to do this meeting, it always books it for 8 hours unless you do some specific incantation in the UI to make sure that it actually books the time you specified. And this is completely that's benign, but it's really annoying. Why did this just break? You don't expect to get in your car. Well, the car is a bad example, but you don't expect to walk into a building and then just, oh, a little corner of it sort of crumbles off, or it starts cracking. We don't expect that, but software is constantly breaking, and I'm sick of that. And that's a benign example, but there are plenty of not benign examples. So, um, some time ago, a couple months, we were helping my grandmother get access to her medical records. This is not associated with patient at all, also medical though. Um, and the sign up flow was kind of difficult, but we were able to get through it. And then once we finally got through this flow, we ended up with an incredibly long username that was a big string of random characters. And so my wife said, this is not going to work. We should reset the username so you can have a nice short name that you can easily remember that you don't have to look up. Excellent idea. So we go through the flow they provided to reset that username, and ta-da, everything lights on fire and explodes, and now we cannot gain access. So that was a few months ago. My grandmother still does not have access to her medical records online because of that. So she drives to the hospital and asks them to look things up for her instead. And this is normal. Nobody is surprised to hear this. This is the experience you have using software anywhere in the world. And so I'm fed up with that. I think it's quite embarrassing as a craft, honestly, that that's the expectation we leave in people's minds is that it's just going to be bad and broken all the time. So I'd love to live in a world where it's not bad and broken all the time, and we have people have the expectation that things work consistently and understandably.
It's a hopeful perspective. We can be better.
It is. It is.
All I have to do is bash all the bugs.
Exactly.
Do I go ba-da-ba-da-ba-ba-ba? No. All right. Any other hot takes you wanna dish out, Isaac? We should be responsible for business logic. Do you think we should start running the world now?
I don't even feel like that should be a hot take. That seems like so incredibly obvious to me. I mean, I think I have a product manager on my team, and he's wonderful, and he does a lot of the work talking to customers and developing these requirements. But then we talk, and there's a lot of feedback, and the ideas I have end up influencing the business logic quite a lot, and
Yeah.
we build way better products because of that. And I think everyone should do that, honestly. And I love talking to the actual users and talking about what their pain points are, and then I can make a suggestion. This doesn't make sense from a business perspective. We should do this instead. That's going to be so much easier for everyone. And that combination of the understanding of how the system really works from a technical perspective, and also the human, the human side, understanding how people are really using it is super. It's an excellent combination that really sets you up nicely to change things in a good way. So I will die on that hill. Software engineers should absolutely be coming up with business logic and intimately involved with how it is defined and implemented.
Right, because you could phrase it another way, and you could say like, if business logic is an abstraction and software engineers are owners of the bridge between abstraction and implementation, you are neglecting a key part of this if you are completely ceding half of that to some other team or something else, right?
Right. And I think the real issue is that you could pretend or have some hope that it's going to work out, that the people responsible for the business are going to be able to perfectly encode the business rules. But that is impossible and does not happen. And so really, uh,
Isn't that the
the
running
software
joke with
engineer,
AI, right? Like, yeah,
oh
as
yeah,
soon
sure.
as we can get clear business requirements, I'm sure we'll all have
Right.
trouble.
Exactly. So
Yeah.
even if you exist in an organization where the expectation is that you, the engineer, are a device that produces code and someone else makes the decision about the business, it's always vague. There are always holes in the spec, and you have to make decisions about what the real business logic that you actually end up implementing is. So cut that out and just acknowledge the fact that you are doing the business logic yourself, and everything will get better.
Okay. I believe it.
And I while we're here, there's one other thing I want to recommend, which is a paper, an essay, Programming as Theory Building by Peter Nahr. Highly recommend reading it. I had heard it mentioned, and I just read it for the first time a few weeks ago, and it really captures a lot of. I feel very, I guess, in tune with the ideas presented there. And one of the big ideas is that what we are doing as programmers is our primary activity is not text production of code. It's building theories about the systems we're operating. And those theories that we build are the sorts of things that exist within people and are sort of social in nature. And you can write documentation, you can write comments, and those are useful, but you can never fully capture that sort of theory. And that theory is what allows us to modify complex systems and understand which way to go, and because we have this theory and we can see what changes are in line with that theory and what changes conflict with it. And so that ties into the business logic thing, where it's like the business logic is so deeply embedded in the theory of this thing I'm building that I, as the engineer, really need to be involved with those decisions there. And it also ties into the assertion thing, which is one of the reasons I think we should be writing these assertions, is that it encourages us to explicitly write down some rules that can sort of help us more quickly work towards that theory. And those rules will always be kept up to date because they're running in our code. They're high commitment. They make your code communicative because it'll tell you when something goes wrong. And ultimately, just push us, act as a nice helping hand with the activity of building a theory of your code base.
Thanks for checking out the Bug Bash podcast. If you want to reach out, maybe with an idea for the show, or maybe you want to be on it, send us an email at bugbash@antithesis.com. Or if chat's more your style, head over to antithesis.com and scroll to the bottom, where you'll find the link to our Discord. Until next time.